California's smoking cliff is not a volcano, but it is a warning. A cliff in Santa Barbara County began smoking again, and the first word many people reached for was volcano. But the more important story is not what this place is called, it is what the smoke reveals about a coastline that can generate heat from within its own exposed layers. There is no confirmed volcanic eruption here, no lava, and no evidence of magma rising under Hope Ranch. What appears to be happening is quieter and more local, but still serious. A chemical and geological reaction inside a coastal bluff that can produce smoke, heat, and sometimes small vegetation fires. California's smoking cliff is not a volcano, but it is a warning. A cliff in Santa Barbara County began smoking again, and the first word many people reached for was volcano. But the more important story is not what this place is called, it is what the smoke reveals about a coastline that can generate heat from within its own exposed layers. That difference matters, because the wrong label can create the wrong fear. This is not a Yellowstone-style warning sign, but it may be a reminder that erosion minerals, hydrocarbons, oxygen, and dry California vegetation can create a hazard without any spark from the sky. The headline makes it sound like the Earth is erupting. The real signal is that the landscape itself may be smoldering. Along the coast near Hope Ranch, smoke rising from the bluff has become a recurring local mystery. Some residents know the nickname, some remember past flare-ups, and firefighters know this is usually less about eruption and more about monitoring a strange source of heat. This is where American Sky Brief becomes useful because the image is dramatic, but the explanation needs to stay grounded. A calm reading of the event shows a place where geology, chemistry, erosion, and fire risk all overlap in one narrow strip of coastal terrain. The latest report brought fire crews back to the area after smoke was seen near the cliffs. Their immediate concern was not volcanic activity, but whether the heat could reach nearby vegetation, damage drainage infrastructure, or create a larger fire problem along the bluff. At first glance, smoke from the ground feels like a volcanic signal, especially when the public nickname already points in that direction. But the evidence described so far supports a more surface-level process, one driven by exposed materials reacting with oxygen rather than deep geothermal pressure. That makes the story less apocalyptic, but not less important. In California, a small and unusual ignition source can still matter when it appears near dry brush, steep slopes, ocean winds, and human infrastructure. The scene near Hope Ranch is visually striking because smoke appears to rise from the cliff itself. To anyone watching from a distance, it can look as though a hidden vent has opened beneath the coastline. That visual impression is the reason the Hope Ranch volcano nickname has survived for years. The problem is that the nickname explains the appearance, not the mechanism. A true volcano is tied to magma, deep heat, volcanic gases, and a plumbing system beneath the surface. The Hope Ranch phenomenon, based on the available descriptions, is instead a recurring bluff combustion event linked to reactive materials inside the coastal layers. Firefighters were called because smoke was visible, and because smoke near vegetation is never something to ignore. Even when the source is unusual, the response still has to focus on practical risk, flame spread, access, wind, fuel, and possible damage to nearby systems. The reported concern about underground drainage pipes is important because it shifts the story from curiosity to infrastructure. If heat erosion or slope movement interacts with drainage systems, the bluff can become more unstable and harder to assess. The most basic fact is that this is a recurring event, not a brand new mystery. Similar activity has been reported in past years, including cases where the smoking bluff was associated with small vegetation fires. That history helps reduce panic, but it does not remove risk. A repeated hazard can still behave differently from one episode to the next depending on moisture, wind, exposed material, vegetation, dryness, and slope condition. What many viewers misunderstand is that smoke does not automatically prove volcanic activity. Smoke only proves that something is hot enough to release visible particles or vapor, and the source of that heat can be chemical rather than magmatic. In this case, the likely source is not deep inside the planet. It is much closer to the surface, where layers of iron sulfides and hydrocarbons can become exposed when the bluff erodes or shifts. Once those materials meet, oxygen-chemical reactions can begin. If heat is produced faster than it escapes the temperature, inside the bluff can rise until smoke or small ignition becomes possible. This is why the event can seem sudden, even if the process has been building slowly. The public notices the plume, but the chemistry may have started earlier in cracks, pockets, or newly exposed surfaces inside the slope. The incident also shows why emergency crews often monitor rather than aggressively attack the source. If the reaction is happening within the bluff material, simply spraying the surface may not fully stop the process. Heavy intervention can also create new problems if the cliff is unstable. Digging, flooding, or disturbing the slope may expose more material, weaken the bluff, or make the site more dangerous for crews. So the operational logic is controlled caution. Firefighters watch the plume, check the vegetation, evaluate nearby structures or pipes, and respond more aggressively only if the heat begins to spread into a conventional fire. This separates the public image from the emergency reality. The public sees a volcano, while responders see a difficult ignition source embedded in a coastal slope. The setting makes the situation more sensitive because Santa Barbara County sits inside a region familiar with wildfire risk. Even near the ocean, dry grasses and shrubs can burn quickly when the weather pattern supports it. Coastal wind can complicate that risk by feeding oxygen into a smoldering area and pushing embers or smoke along the slope. The ocean nearby does not automatically make the cliff safe from fire behavior. The key point is that the Hope Ranch event is not dangerous because it is volcanic. It is potentially dangerous because it can produce heat in a place where vegetation erosion and infrastructure are close together. That is a more accurate frame than the nickname provides. It also gives the public a better way to understand why crews respond even when there is no eruption threat. The driving force appears to be a combination of exposed geology and chemical oxidation. This is a very different engine from volcanic heat because it does not require magma or deep geothermal circulation. Coastal bluffs are layered records of older environments, and those layers can contain minerals and organic-rich material. When the ocean, rain, groundwater, or gravity cuts into the cliff, those buried materials can be brought into contact with air. Iron sulfides are especially important because they can react with oxygen. That reaction can release heat, and under the right conditions, the heat can accumulate inside the bluff instead of dissipating harmlessly. Hydrocarbons add another layer to the problem because they can act as combustible material. When reactive minerals, carbon-rich compounds, oxygen, and insulation come together, a slow, hidden reaction can become a visible smoke event. This is not the same as someone lighting a match. It is closer to spontaneous combustion, where heat is generated internally until the system crosses a threshold. There are familiar comparisons that help explain this without exaggeration. Coal seams can burn underground compost piles, can heat internally, and oily materials can ignite when oxidation produces heat faster than it can escape. Hope Ranch is not identical to any single one of those examples, but the principle is similar. Fire can begin when chemistry, fuel, oxygen, and trapped heat align. Erosion is the trigger that often gets overlooked. Without erosion or slope movement, reactive materials may remain buried and isolated from the oxygen needed to drive the process. A small landslide can expose fresh surfaces. Rainfall can open cracks, groundwater can weaken layers, and drying conditions afterward can allow air to circulate through the bluff. That sequence is important because the visible smoke may not appear during the wettest moment. It may appear later after the slope has shifted, dried, and begun to react internally. This is why a smoking bluff can be tied to weather, even though it is not a weather event in the usual sense. Rain, wind, humidity, and drought conditions can all influence the timing and behavior of the reaction. The word solfatara or solfatara can create confusion here. In volcanic areas, sulfur vents are commonly associated with geothermal systems, where hot gases and steam rise from deeper heat sources. At Hope Ranch, the use of that kind of label should be treated cautiously. Sulfur-related compounds may be part of the chemistry, but that does not automatically mean the site is volcanic or geothermal. That distinction is one of the most important corrections in this story. Sulfur, smell, smoke, or heated ground can appear in different settings, and not all of them point to magma. The evidence described so far fits a surface or near-surface combustion process better than a volcanic system. That is a fact-based interpretation, not a guarantee that every detail of the event is already known. There are still uncertainties that only site assessment can resolve. Crews and geologists would need to evaluate the exact location of heat, the condition of the bluff, whether pipes were damaged, and whether the reaction is isolated or spreading. This is where the story becomes more than a local curiosity. The same coastline that gives the area its beauty also creates the conditions for erosion, exposure, and hidden instability. Bluffs are dynamic landforms, not permanent walls. They retreat, crack, slump, absorb water, release material, and sometimes expose layers that were never meant to sit in open air. Human infrastructure can complicate that natural process. Drainage pipes, roads, landscaping, irrigation, and development can change how water moves through a slope. If water concentrates in the wrong place, it can weaken a bluff and accelerate erosion. If erosion exposes reactive material, the chemistry can begin, and if heat damages infrastructure, the problem can feed back into the slope. This does not mean a major collapse is happening every time smoke appears. It means the smoke should be treated as a signal that the bluff's internal conditions deserve attention. The weather layer also matters because fire danger is never determined by ignition alone. It is determined by ignition plus fuel dryness, wind slope, humidity, and response access. On a calm, moist day, the same heat source may remain limited. On a dry, windy day, with receptive vegetation nearby, the risk profile changes quickly. That is why a small plume can deserve a professional response. The hazard is not only what the plume is doing now, but what it could ignite if the surrounding environment is ready to burn. The Hope Ranch volcano matters because it is a lesson in how misleading natural signals can be. A dramatic image can point the public toward the wrong category of danger, even when the real danger is still worth taking seriously. The first conclusion is simple. This does not mean Santa Barbara is experiencing a volcanic eruption. There is no need to interpret the smoke as lava movement, magma pressure, or a new volcanic system forming under the coast. The second conclusion is equally important. Non-volcanic does not mean harmless. A chemical heat source inside a dry, vegetated bluff can still create a fire problem. That is the balance the public needs to understand. The event is not a reason for volcanic panic, but it is a reason for local caution. For nearby residents, the practical concern is whether smoke remains isolated or begins interacting with vegetation. Once brush catches, the event stops being unusual geology and becomes a conventional wildfire response. The location also matters because bluffs can be difficult places for crews to access. Steep terrain, unstable edges, limited approach routes, and changing winds can make even small incidents more complicated. Another real-world concern is infrastructure. If drainage pipes, underground lines, or slope control systems are affected, the smoke event may reveal a broader maintenance or stability issue. That does not mean every pipe is damaged or every slope is failing. It means responders are right to check, because heat and erosion can create problems that are not visible from the road. The broader lesson is that landscapes can hide slow processes until they suddenly become visible. A coastline may look calm for years, then a small plume reveals that chemistry and erosion have been working quietly inside it. This is why the phrase recurring phenomenon should not be used to dismiss the event. Recurrence gives context, but each episode still needs to be judged by current conditions. A familiar hazard can become more serious if the surrounding fuels are drier than before. It can also become more complicated if the bluff has changed, if new cracks have opened, or if recent weather has altered the slope. There is also a communication lesson here. Calling it a volcano gets attention, but it can also send people looking for the wrong evidence. People may ask whether an eruption is coming when the better question is whether a smoldering bluff can ignite vegetation. They may ask whether magma is rising when the better question is whether erosion has exposed more reactive material. This is the difference between sensational language and useful analysis. Sensational language makes the event feel bigger, while useful analysis makes the risk clearer. The fact layer is that smoke was reported, firefighters responded, and the site has a history of similar activity. The interpretation layer is that the likely mechanism involves near-surface reactions and exposed bluff materials, rather than deep volcanism. The uncertainty layer is that the exact condition of the slope pipe's fuel and heat source can vary during each flare-up. That uncertainty is not a weakness in the analysis, but a reason for measured monitoring. What viewers usually misunderstand is that natural hazards do not always arrive in familiar packages. Not every smoke plume is a wildfire, not every sulfur smell is a volcano, and not every ground heat source comes from deep earth. Some hazards are hybrids. Hope Ranch sits in that hybrid category where geology creates the source, chemistry creates the heat, weather shapes the risk, and firefighters manage the consequences. That hybrid nature is what gives the event its value as a case study. It shows how a small local incident can teach a wider lesson about coastal change, fire exposure, and public interpretation. For California, this matters because fire risk is not only about lightning power lines, campfires, or human activity. Rare and unusual ignition sources can also matter when the landscape is dry enough to respond. For coastal communities, it matters because erosion is not only a long-term property issue. Erosion can expose materials, alter drainage, destabilize slopes, and sometimes uncover chemical processes that were previously sealed away. For emergency communication, it matters because the public needs accuracy without complacency. Saying not a volcano should reduce the wrong fear, but it should not make people ignore smoke coming from a slope. The best frame is this: Hope Ranch is a non-volcanic smoking bluff with a recurring combustion risk. That description is less dramatic than volcano, but it is more useful for understanding what crews are actually watching. And in hazard analysis, usefulness matters more than drama. The goal is not to make the event sound larger than it is, but to make the real risk easier to see. The smoke rising near Hope Ranch is not evidence that a volcano is waking beneath Santa Barbara. It is evidence that a coastal bluff can become chemically active when erosion exposes the right materials to oxygen. That makes the event smaller than the nickname suggests, but more meaningful than a curiosity. It shows how fire risk can emerge from the landscape itself, without lightning, without a campfire, and without a human ignition source. The most important takeaway is not panic, but precision. When we name a hazard correctly, we understand what to watch, what to ignore, and what kind of response actually makes sense. Hope Ranch is not warning us about magma. It is warning us about the hidden connections between geology, weather, erosion, infrastructure, and fire. That is the kind of signal that can be easy to miss when the headline is louder than the science. If you value calm, data-led analysis of unusual weather, fire, and Earth system events, stay with American Sky Brief.